So we think about, having a slope of 0, being a horizontal line, looking like this. So we're saying every point on there has the same y coordinate, right? That maybe that's -3, 3, and that's -1, 3, and this over here is 4, 3. So the equation of that line would be just that y equals 3. Okay, so it's a very simple equation to write, but we think of horizontal, the x-axis is horizontal, but y lines are horizontal. Okay, so it kind of goes against what we think. And in the same way, when we talk about vertical lines, every point on there, so again, if I think about that's 5, -4, and then here's 5, 0, and then here's 5, 3, or something like that. So they all have the same x coordinate, and so the equation of that line would be x equals 5. Very easy equation to write, but we just think up and down, that's a y-axis, right? But it's an x line. So x lines go up and down, y lines go horizontally. Y lines have no slope, x lines have undefined slope. So just, all right, finishing up section 2.2, talking about horizontal and vertical lines. Every level I've taught algebra at vertical and horizontal lines confuse students, just because it's a little bit counterintuitive on how you write their equations. They're actually absolutely the easiest linear equations to write, but you have to remember something. And again, that it goes against what you would think it does, so it just messes with people. So when we talk about horizontal lines, when we say that a line is horizontal, it's because every point on that line has the same y coordinate. So that means that we can write the equation as y equals just a number, has the same x coordinate. So we go back and look at things to think about. And so how do you use that to write the equation of a line? But again, it's really something you have to remember, that horizontal lines are y lines, vertical lines are x lines. So it's counterintuitive, it goes against what you think. So there's just a trick to it, you gotta remember that. Otherwise there's really no way around it. So write the equation of a horizontal line that passes through the point. There's really no work to do here, it's all thinking. Horizontal lines, that means it has a slope of 0, okay? Horizontal lines are my y lines, so it should be, y equals some number. Well, what's y equal to here? Well, y is equal to 4. That means every point has to have that same y value if it's a horizontal line. What's y equal to on this one? What's the horizontal line that goes through this point? It's going to be y equals -7. It's almost no work, it's all thinking. Okay. So in the same way, I want to write the equation of a vertical line. That means the slope is undefined. Okay. That means I'm going to have all the same x coordinates. There's going to be no run, so all the x coordinates are the same on something like this. So I'd say, well, what's my x value? Oh, it's -1. So the equation of the vertical line is x equals -1. The equation of the vertical line here would be x equals 2. So no work, all thinking. Okay, you got to remember that trick. Parallel and perpendicular lines, definitely something you guys have talked a lot about before. Two lines parallel, of course, if they lie in the same plane and have the same slope. Okay, so if they're going in the same direction, right? That's if lines go in the same direction, that means they won't cross, and then so that means they have to have the same slope, which slope and direction are the same, kind of a similar concept, but different y-intercepts. So if we think about what parallel lines look like. So they have different y-intercepts, but the same slope. Okay. So what's the slope of the line that's parallel to the following lines? So if I want to know the slope of the line, I would love to have it in slope-intercept form. So this one's really easy. So the line that is parallel to this one would also have a slope of 1/5. Okay. Now the second, right, it says what's the slope of the line that's parallel to this? Well, this line is not in slope-intercept form, so I can't see its slope. It's in standard form. So standard form does not tell us the slope. This is not the slope of the line. It's a very common mistake. So you need to get that y by itself first. Okay, so I get it into y equals mx plus b, so I'm going to solve for y. So use what we talked about with like solving a literal equation here. So subtract the 4x to the other side. So that would give me negative 3y equals negative 4x plus 5. Then I'm going to divide by negative 3. And I would suggest you do these individual divisions here. So that would give me y equals, so here I have negative 4 and negative 3, so it's going to be positive 4/3 x. And then 5 divided by negative 3 would be negative 5/3. But there really wasn't any point in me figuring that part out. It's no use there. The whole point, the whole reason I wanted to do this was I wanted this number right here. So a line parallel to this one would also have a slope of 4/3 or 4/3. So that's all they're asking. What's the slope of a line parallel to that? Okay. So you're just looking for the slope. If it's given, use it. If it's not given, you need to find it, and then you answer the question. Okay. Write the equation of a line in slope-intercept form, parallel to this line, but passes through this other point. Okay. So they're giving us one line. Again, to kind of picture what's going on here. It says the y-intercept is 5, has a negative slope, so it's going to be, so this line is going to look something like this. Y-intercept at 5 goes down, it's negative slope, so it's going to do something like that. They want us to pass through negative 6, 1, which can be over here somewhere. I want it to be parallel to that. Okay, so our line's going to look something like that. So, what we don't know is what the y-intercept is, right? That's the information we don't know. We could sit here and graph it out real nice, and use graph paper and all that stuff, nice straight edge and all those things. That takes time and tools that you may not have. Okay, so how do you do it algebraically? So what's important here? Well, we know the lines are parallel, which means they have the same slope. Okay, and so that means I know the slope of my new line is also going to be negative 3/4. Right? But what don't we know, right? We don't know what b is. So we need to find that. Okay. Common mistakes, people think that that's our b value over there. That's not our b value, it's the b value of the other line. Another common mistake is that people think that's the b value because it's a y value. Well, that's this point over here, not this point here. So that's not it. Okay. So there's different ways to do this. One is to plug it back into point slope form because we have a point and we have the slope, right? So since we talked about that already, we'll just use that. So y minus y1, which is 1, equals the slope. So negative 3/4 times x minus x1. So x1 is negative 6. So minus negative 6 would be plus 6. I'm going to distribute. So that would give me y minus 1 equals negative 3/4 x. Negative 3/4 times 6 is 18/4, which is 9/2, so which is 4.5. Now I notice I went ahead and turned that into a decimal because that's a point. The y-intercept is a point on the line, so points are okay to represent as decimals. I would never represent the slope as a decimal given the choice. Always leave a slope as a fraction. I need to add 1 to both sides. So if I add 1, y equals negative 3/4 x. Negative 4.5 plus 1 is negative 3.5. And you see that our answer makes sense because we kind of thought it might cross below the y-axis, but that was a very rough sketch, so it's not really a great idea, but see that it is doing that. So here's the equation of that line that is parallel to this one, so notice they have the same slope, but goes through this point. All right, so we've done parallel, and there's also perpendicular. So perpendicular lines cross at 90-degree angles or intersect at 90-degree angles. So we look at something that does something like this. What we're going to do is we're going to start off by looking at the slope of the line we have, which is line C. So looking at the slope there, so what's my rise, what's my run? Looks like from point to point, rising 3, and then we're running 1. So we have a slope of 3/1. And what we're going to do is we're going to rotate that triangle over around this point. So we're going to rotate it around that point 90 degrees, and then look at the slope of our line then. So, probably been a little while since you guys rotated. I'm going to bring this line here down 90 degrees. You notice that this goes 90 degrees that way, so it's going to go but 3 units. So I'm going to go this way, 3. So there's another point that I could use. I'm going to go from that point to that point. Let's get my straight edge here. Tricky to get it lined up exactly where I want on the computer. That's pretty close. All right, so then here's line D. I want to find line D's slope. So if I go from point to point, I'm going down 1, and then right 3. So rise or run -1/3. And so looking at the relationship between those numbers, 3/1 and -1/3, perpendicular lines have slopes that are opposite. So one is positive, one is negative. And they're reciprocals, so that means the fractions are flipped. So just real quick, what our opposite reciprocals look like? Other examples. So if the slope of one line was negative 4/5, then the slope of the second line would be positive 5/4. If the slope of one line was 4, then the other slope would be -1/4. So opposite reciprocals for perpendicular lines. So a pretty similar example to what we did earlier. What's the slope of a line that's perpendicular to the following lines? So I need to look at my slope. So in this case, again, 1/5. So that means the slope that is perpendicular to that would be opposite, which is negative since that's positive. And the reciprocal of 1/5 is 5, or 5/1. We saw earlier that this one, once we solved, was, let's see, 4/3. So that's our original slope. And so that means the opposite of 4/3 would be negative, and then reciprocal would be 3/4. So using what we found earlier. Don't need to do it again. Okay. All right, and last one is, so we're given a line that we want to create another line perpendicular to it that goes through this point. So again, if it helps at all to sketch out real quick, definitely not necessary. So this line here has a -3 y-intercept, so it starts here. It has a positive slope though, a pretty steep slope too, 5/2. It looks something like that. And the 0.4, -3. So somewhere maybe like over here, we have that 0.4, -3. We want the line that's perpendicular to it. So something kind of like that. We're going to try to find that orange line. So we need to look at our slope of the line we have. So that's our slope, but we got to make sure that we flip it. So the slope that we actually want is going to be -2/5. So that's our new slope. And we still need B, right? Just like we did before. B equals what? So the other way to do this, so I showed you one way using slope, that's the point slope form. The other way is to use y equals mx plus b. All right, we're trying to find out what b is. If we don't know what b is, that means we have to know everything else. Well, we know what m is. We just found that. And we also know an x value. And we also know a y value. So I can plug all of those things in. So my y value is -3 equals m, which is -2/5, times x, which is 4, plus b. We're going to solve for b. So 2/5 of 4 is 8/5. I get -3. So now I'm going to add 8/5 to both sides. Well, 8/5 is equal to 1.6. So -3 plus 1.6 is equal to -1.4. Again, I'm okay representing b as a decimal because b represents a point on the y-axis. So if I told you to plot the y-intercept of this would be -7/5. If I said plot 0, -7/5 on the y-axis, it's actually kind of tricky for us to plot in proper fractions. Not very good at it. But if I said plot the point, y-intercept is at -1.4, it's pretty easy to go down, and say, oh, it's about 1.5, down. So it's actually easier to plot decimals for the y-intercept. But again, the slope, since it's the rise and the run, the individual numbers represent something. You don't want to turn that into a decimal. So there's my y-intercept. So y equals, so our slope was -2/5 x minus 1.4. All right, last problem. So we want to determine algebraically and graphically whether following lines are parallel, perpendicular, and either. Either way, if I want to do it algebraically or graphically, I need to see the slope. And so my first thing I want to do is get these into slope-intercept form. So I'll take this equation, I'm going to solve it for y. In order to do that, I'm going to get the x to the other side. So that'll give me 2y equals x plus 10. And then divide both sides by 2. And so that'll give me y equals, so I have a 1 over 2, so 1/2 x, and then of course 10 divided by 2 is 5. I'm going to go ahead and graph that. So my y-intercept is 5. My slope is 1 over 2, so rise 1, run 2, rise 1, run 2, rise 1, run 2, so forth. Or I can go backwards, down 1, left 2, down left, down left, down left. So my line should look something like that. I will zoom in a little bit before I do that. So there's one line. And then go for the other one. So I need to get y by itself here, so that's one's a little simpler. I'm just going to divide both sides by 2. Say y equals, again, there's a 1 in front of the x, so 1/2 x, and 4 divided by 2 is 2. So I have enough right now to determine algebraically if they're parallel or perpendicular or neither, because look at their slopes. Their slopes are the same. So these lines should be parallel. Don't lie across that. Let me look at graphically, 1/2 x plus 2. So I have a y-intercept of 2, slope of 1 over 2, rise 1, run 2, fall 1, left 2. So we can see as we draw that line in there that it is parallel to the other one. So sketching lines out to see if they're parallel perpendicular, is actually just a guess. The true way to determine if lines are parallel or not is algebraically that if they have the same slope, then you know for sure that they're parallel. So you guys should be able to do 29 through all that now. And yeah, and then so this will be the last paper assignment. Then we'll be moving into the web assign. So from there. Thank you.